So in the beginning of week 1, I believe, or week 2, I talked about the approach where I start with the big blocks, the major pieces of the sim, and sim those first, and then and start layering things based on their size and how heavy they are or how much they're contributing to that sim. Things are at the top level, generally they don't contribute that much to the structure of the sim, so you don't have to include those in the main layer that has all the complex constraints and things like that. And another example is the windows frames and the glass for these windows as well as these guys. So let me find the geo. I'm going to use V12 for consistency. Okay, so this sim, we have windows here, windows frames as well as glass, and I'm gonna import. Actually, let's do this. I'm gonna object merge this. I'm gonna copy these two guys. I'm gonna do it at a different location, and we'll copy the upres workflow. Okay, so what we have these window frames, and then the glass. So first of all, let me transform everything so the scale matches. Okay, and I'm gonna turn off tint back faces. Cool. And we need to fracture these guys. So let's do this. Let's do it for each connected pieces. I want to fracture each group separately. And I'm going to do a VDB from Polygon. I'm not going to worry too much about the wood pattern in this example. I mean, it's tricky, but that's not the point here. And let's gather some points. Maybe 100. Do Voronoi fracture, not the old. Okay, and let's make sure the geo is fused. Let's try with the Voronoi old. See if the fixes the issue. Nope. So let's see what's happening here. Let's divide the geo. Yeah. There's an issue there. Let's add more points, see if that helps. There's another issue there. And this is mostly because of the inside faces. So if we turn off the create inside faces, it fixes that issue. Actually, let's try something. Let's see if we can create our own inside faces. So for each named primitive, I'm going to do a second for each loop and loop over these guys. And let's just use a fillet node, a polyfill. Set it to triangulate and see if that helps. And I'm not gonna worry too much about the grouping for now. Sorry, let's see. So it did a better job, but this one has an issue. So okay, let's just stick to this for now and fracture these wood frames. It's not gonna matter too much. We can use this as well. Okay, so we have fractured these guys, and looking at this part of the geometry is not going to this piece or this block is not going to affect the sim by itself, but it needs to transform properly with the sim. So what I'm going to do, I'm going to transform the kinematics from the original, from this point cloud onto these guys. And the way I'm going to do that is by first transferring the name attribute. So let me use this. This is the packed fragment. Let's transform, use a transfer attribute, and let's make a copy of the name. Call this main name is equal s at name. And I'm gonna assemble these guys to give them a good name attribute, because from here it's not gonna work. So we'll call this wood frame or window frames, and naming wood frames. This is good, and then I'm gonna pack that. So let's copy this guy. And now let's transfer that main name from here into this. Okay. I'm gonna copy this as well to get a main name, and then I'm gonna use a transform piece. And tell it to use the main name, of course. Alright. And there we go. We have our wood sim, 0 time spent, and we basically don't have to worry about this block at all. So let me do one more thing. Let me transform the entire geo as well. So that's the main sim, and this is with the wood frame. And let's take a look. And again, we're just inheriting the motion after transferring the name attribute. And see, for example, this block here, it just works. There is nothing required for us to get this to behave like this. I mean, this structure itself is not going to hold the wall and the concrete from doing whatever it's doing. We may be losing a bit of physical accuracy, but this is going to work fine. Okay, so the next part is, how are we going to do the glass? So for the glass itself, this is not going to be static. You know, we have to see if a piece of wood, for example, goes through the window, we want to see the glass falling and interacting. So we cannot use this technique. We cannot just transfer them. Okay, and the idea that I use is, I basically look for the part where the glass is attached to. So this glass here is going to be attached to all these guys. Okay, so if we take this block and fracture it in a glass-like pattern, we can say, okay, I want all the pieces here to basically get constrained to the neighboring blocks, to the neighboring pieces here. And this way, when this layer moves, it's going to move the glass with it. Okay, so there is a constraint network that we're going to create. But we don't want everything to be constrained to the wood frame. We actually want just the tiny bit surrounding the frame to be glued to that. So we get the glass shard attached to the borders, and then we want everything else to be active. So let's do this. Let's first fracture the glass, and I'm going to use for each connected piece, and I'm going to use the glass fracture from the RBD fracture material node in Houdini 17. And let's fuse and divide the geometry, make sure everything's good before we use it. And let's use an RBD fracture and change it to glass. I don't need constraints. I'm gonna increase this. I don't need the edge noise. Okay, let's take a look. Cool. Let's increase the number of points. something like that. And let's see how this looks on all the other pieces. So this is what I'm going to do. I'm going to isolate one window from the bottom and one window from the top. I'm going to use this so it's faster to work with, and I'm going to also use a compiled block. It looks like there's something that compiled block is not liking, maybe the RBD fracture itself. But anyway, we have 18 pieces, so should be fine. Okay, so we have some glass. I'm gonna work on the pattern a bit more. So let's do this. Let's isolate this block. I basically want to get a lot of uniform, something like that. A lot of uniform patterns. I don't want the radial stuff too much. And then lower the impact spread. Set this to 0.1. I think this is too much. Okay, I think we'll go with this for now, and let's add back some geometry. Almost done. I think there's too much details, but it's fine for now. Okay, so what I want to do now is I want to create a glue constraint that links this geometry to the wood frames, and to be honest, I'm not happy with this. Let's do a simple VDB from Polygon. And scatter some points. I'm gonna do 100 points. I'm gonna use a point replicate. 10 points. I'm gonna lower the sphere. I'm gonna do something like this. Yeah, I'm gonna go with this pattern instead. So let's do 50. And let's increase the number of points. And let's scatter some points on the surface just to get another level of details. And merge all of this. Okay. Cool, so the next part is we're going to constrain this geometry onto the neighboring. Yeah, I really like this much better. Maybe I need to spend more time with the RBD fracture node, but I'm pretty happy with this so far. Okay, so the idea is we want to constrain these guys. Let me change the frame. We want to constrain this glass to the neighboring wood piece close to them. So let's do that. I'm going to show the solution. So let's first generate a name attribute. Windows glass. Okay, and then I'm going to do let's talk about it first. If I merge this and this guy, and let's do an unpack geo, so we have the raw. We can do connect adjacent pieces. And this is linking now the wood, the glass into the wood. But I cannot easily separate these guys. I cannot easily separate the shards that are close to the edge of the wood frame. I'm also getting all this constraint that it's going to hold the static wood pieces, which I don't need. So I only care about attaching the glass to the windows, and for that I'm going to use something different. So I'm going to use a for each loop, and I'll show the idea, and then you guys it will make sense once we do it. So we have a name attribute. I'm going to convert all this into 1 point. So let's use let's average all the positions into 1. And let's delete geometry but keep points. I just need the points. And we have to make sure that we have a name attribute. So let's promote the name attribute at the upper level. From prim to points, and then make sure we don't delete it. Okay. Now we have multiple points. I just need 1. So I'm going to use another fuse node. Say keep unused points, and that will give me 1 point. And let's set this to 0 so it only runs once. Okay, and that's our name attribute. Cool. And once I do this, I'm going to use a ray node. Okay, and I'm gonna ray this point onto the geometry of the frame. So let's see. So we have one piece that is that, and if I template the frame, this piece is there, and then I'm going to use a ray node. Let me check something. Yeah, so I'm going to use a ray node, and after I've used all those points, we only have 1. I'm going to ray it onto the closest geometry from the second input. So I changed this method to minimum, and that's going to use the shortest path basically, and see how that point snapped there. I'm going to merge these two guys now. Okay. And I'm going to connect them. And that's our constraint line. But right now we only have one correct. For the constraint to work, we need the points to have a name attribute that represents what they're constraining to. And right now both points have the same attribute. So what we need to do, what we can do with the ray nodes, we can import attribute. And I'm going to do that. I'm going to say import attribute from hit, and I will make sure to delete the name attribute here, so that when I inherit that from this, it's going to import the new attribute. So here you see there is no name attribute, and then there is a name attribute. Sorry. One more thing. We need to promote this as well, because the name attribute is a primitive. So let's do the same thing. Now if I middle click, there's the name attribute. If I look at these 2 points, they have correct names. And if we loop over all of the glass, we're gonna get one constraint from the center of the piece to the nearest geometry from the wood frame. And that's how it looks like. Okay, so each piece of glass now has a wire that connects to the closest. And this is great, because what we can do is we can measure the length of these primitives. So let's do that. And it's going. Okay, so now we have a length attribute. I'm going to promote that to, actually that's fine. Let's use a color node. And I'm gonna view this attribute. So it's a primitive attribute, ramp from attribute, it's length. So see how we get this coloration now? We can do this. Okay, and all these black points, all these points, they are going to be attached to the wood frame, and then everything else we're going to use as a live constraint. So let's isolate both of them, and let's isolate each group. So if the color is less than 0.5, I want to delete the primitives. If not, I want to keep the primitives. So these are going to be active constraints, and these will have a potential to break. These guys will never break. And let's set up the constraint attribute. So as constraint name is equal glue wood, glue glass ever, and this we're never going to break this guy, and we're gonna constrain the position only. The glue constraint only stores the position, but just to be safe, we're gonna declare that here. And then for these guys, we're gonna say glue glass break, and it's also position only. So let's merge this and call it constraints glass. And then what we need the pack data of the glass. So let's do that. Glass RBD, and this is going to be glass CST. And let's assemble these guys. Pack them. And then we're going to do the same thing for the wood, which is here. And right now, let's see, it's packed, so we're good. I'm going to just say out wood frames. And I'm going to copy this, the upres node, because we're going to turn a few things on and off with glass. Okay, almost there. Let's copy this guy, and I actually don't need any of this for now. I'm just going to use the wood frame and the constraint. So let's do RBD packed object, I'm going to call this wood frames, and this is going to be an animated static object. And then this is going to be active. RBD packed object. Windows glass. Okay, that's active, and let's take a look. Cool, so we have there the glass there, and let's hit play. We should see all this transform, and the glass is just gonna fall down. Yep. Okay, so let's do this. Let's create a constraint network, and let's go up, and we're gonna import this guy, and we need two glue constraints. This is going to be never break, glue glass never. I think that's the name, not so sure. And then we need the glass that breaks. And for that, we're going to set it to 10,000 to start with. We'll see how that goes. Let me check the names. Glue glass never, glue glass break. Looks good. Okay. And let's see. Doesn't look like it's working. I don't see the constraints here. Yeah, and it's erroring as well. Okay, so let's see what's happening. We have these primitives. Oh yes, of course, we need to set this to primitive attribute. Okay, we have a name attribute. Here, I'm gonna delete that. I don't need that. It shouldn't be a primitive attribute. Don't need the length at this point. Don't need the class. I don't need the color. I don't need the normals. And that's it. Okay. It should show then. Okay, let's keep checking. Oh yes, constraint. Stuff like this. That, okay, you can spend a whole day trying to figure out. Okay, let's see how this is going to work now. Yep, there we go. Our glass is attached to the wood frames, and it is fracturing as soon as it interacts with something. So I think it's too strong at the moment. We want it to be quite sensitive. And I'm also going to add the wood structure. Hope it works, because I know it's gonna the wood piece is gonna interact with the glass. So let's see how that looks like. I think it's still too strong. No, it's working. We could also test with, oh yeah, we definitely should do this test. Okay, I think it's still too strong. And the test is, I want to see how much geometry, how much glass pieces are staying attached to the wall forever, to the wood forever. So I'm gonna disable this, which holds the center basically. I'm gonna disable the wood as well. And now everything that is not attached is gonna fall down, and only the parts that is attached to the shell is gonna stay. So it's too much. You see already too many pieces there. We could definitely lower that. So let's do that with the color node. Okay, let's see. Yeah, much better. Okay, so let's set this to 800 only. And all this entire block is attached to that small piece, which is not great, but there's not much we can do. We can fracture the wood frame even more, so there is a higher chance of them capturing a different piece. But this is basically how the system works. And that's the glass properly interacting and getting attached to the wood frames. I do think it's still very strong though. But maybe once we add everything, it's gonna look better. So let's hit play. Yeah, definitely, it's working. Okay, so the next thing would be to turn on the fracture on all of them. Fracture all the windows and just cache it out. Save the high-res geometry. Pardon me. Save the high-res geometry to disk, and this is the technique to use. Thank you guys for watching, and see you in the next video. Bye bye.